In this video, I just wanted to take a couple minutes to talk through setting up equations from word problems if we were going to have three variables in the word problem. So solve three variable equations with context. The word problem is that context. So you had a task of several problems you need to complete questions 1 through 5. Question 6, though, is on that PDF. So I'm going to read through question 6 with you here and set up this equation, these three equations that are needed. So the measure of the longest angle in triangle is 10 degrees more than the sum of the measures of two other angles, and 10 degrees less than 3 times the measure of the smallest angle. Find the measures of the three angles of the triangle. So quite a mouthful, but if we define our variables and break it down, we can write the three equations and then we can solve. So sometimes it helps just to draw a picture. And obviously this might not be drawn to scale, but we have a triangle and we have an angle X, Y, and Z. So we can have X be angle 1, Y is going to be angle 2, and Z is going to be angle 3. Okay, so we have our angles defined. And so we know the largest angle is 10 more than the sum of the measures of the two other angles. So since Z is the third angle, I defined it as the largest angle. Okay, so I said Z is the sum of the other two, so that's going to be X plus Y plus 10, because Z is 10 more than the sum of the other two. We also know, okay, because it says the word and right here, I'm still referring to this largest angle. Okay, so Z is also now 10 less than 3 times the measure of the smallest angle. So if I called X the smallest angle, if I take the smallest angle times 3, Z here, Z is 3 times the smallest angle minus 10 because it said 10 less than. So Z is 10 less than 3 times the angle, the measure of the smallest angle. Okay, and now the last part is not in the story here, but what do we know about triangles? That's right, triangles add to 180 degrees. So we know X plus Y plus Z must equal 180. So now I have three equations and I have three variables. So what is really cool is that this equation right here doesn't have a y in it. So if I was going to solve this problem, that's the first thing that catches my eye. I would probably take this equation here, this top one, and plug it in. Well, I wouldn't plug it in because it has an x and a y. I would rearrange this top one to make it be in terms of x, y, and z, and I would eliminate y. And if you could eliminate y, then we could solve. You also could eliminate the x. So something really cool happens here when I rearrange these in terms of x, y, and z. So if I take this top equation and I rearrange it to look like the bottom, it's going to say z minus x minus y. If I subtract the x over and I subtract the y over, equals 10. And what happens if I add it with this bottom equation? I'm going to make that look like a z, so it doesn't look like a 2. I'm going to rewrite it so it's stacked then. Z plus x plus y equals 180. And if I add these up, x and y both eliminate at the same time. And that's magic when you're doing problems like this. And so that's one approach for getting started with this problem. Okay, so if you want to finish out this problem, I can give you a hint that you should get z is 95, and then find your x and y, plug it all back in, and you can check, if you got it right or wrong. But anyway, in these videos, I just wanted to give you a heads up of like, how do I set up these equations? Okay, so if you're still with me here, I'm going to actually set up number 1 with you. Okay, so first of all, if I want to define my 3 variables, again, I'm going to use x, y, and z. Okay, and if I read this problem, number 1, it says the sum of the 3 numbers is 16. The largest number is equal to the sum of the other 2, and it's 3 times the smallest number is 1 more than the largest. I find the 3 numbers. So I'm going to say that x is the smallest number. Okay, y is going to be my middle number. Sorry, my slate is not writing very well. And z is going to be my largest number. So if I read the first statement here, it says the sum of the 3 numbers is 16. Well, x plus y plus z must equal 16 then. It says the largest number is equal to the sum of the other 2. So I defined z as the largest number. So z must equal the sum of the other 2, and 3 times the smallest number is 1 more than the largest. So 3 times the smallest number is, so I use an equal sign, is 1 more than the largest. So that would be z plus 1. So what's really cool about these 3 equations is I already have z by itself in one of them. I do have though, and in this bottom equation, I don't have a y. So I would want to eliminate x. Well, I'd want to eliminate y, excuse me, with the top 2 equations. I'd want to eliminate y so I could get, so I could use that bottom equation. So remember that sometimes it's helpful to put these all in standard form. Okay, so for instance, this top equation, x, y, z. What if I did that with this bottom equation? Okay, I would subtract x over, subtract y over, so I would have negative x minus y plus z equals 0 then. So I could get, this would be equivalent to this equation here, okay? Then if I wanted to get this one in standard form, I would need to subtract that z over, and I would have 3x. Now I'd have a 0y, so if you ever wanted to have 0y, you could, okay, minus z equals 1 by, again, subtracting that z over. However, I think what you'd probably want just for this equation is 3x minus z equals 1. So again, this is equivalent to this bottom statement here. And it looks like, just like in that other example I showed you, what was really cool is if I add these top two equations together, this one here and then this one, the equivalent one, my x's and y's are going to cancel out. And so I'm going to get a value for z immediately. Then I could plug that in down here, get my value of x, plug both of those back in, and get my value of y. So these are not as maybe intensive as some of the problems you were doing in IXL for the first day with the multiple steps or in the video you watched for yesterday. However, setting up these equations is sometimes half your battle. So let me know if you need any help setting up equations. Take your time, read the problems carefully, define your variables, and I think you'll be just fine.